Good afternoon. Welcome to the webinar. Thanks for joining us. This is a very exciting time for us at Cambridge Intelligence as we're introducing a brand new product called Chronograph for visualizing timelines. And what we're going to do is we're going to spend 30 minutes showing you a little bit about how it works and what sorts of use cases Chronograph can be used to visualize. So just as a way of introduction, this webinar is going to be hosted by me and Dan. So I'm Corey Lanham. I've been doing graph things for about 2 decades now, building solutions with traditional graph visualization, timeline visualization, and a whole bunch of other different techniques. And I've written a book about it back in 2016 about graph visualization and how graph visualization can help improve projects at a practical level. The meat of the presentation is going to be shown by Dan Williams. He is our head of product management and has helped build Chronograph among Cambridge Intelligence's other graph tools that you may already know. I do want to let you know that the webinar is being recorded, so if you want to pass this along after the fact to anybody who wasn't able to attend live, feel free to do so. And if you have any questions, definitely ask those in the questions panel that's on the GoToWebinar panel that's on your screen, and we'll address those at the end. So this is our agenda, but we've already talked about the introductions. You know who I am, you know who Dan is. I'm going to go through what a timeline is and why it's useful under certain circumstances and why it's helpful to be a different view of graph data than your traditional link chart that you may already be familiar with. Then I'm going to pass that over to Dan, who's going to show you some examples of our tool Chronograph, which is a new visualization for looking at timelines. We'll talk at the very end about how you can get access to Chronograph. We're in the early access phase, which basically means that the product isn't released for sale yet, but we are letting some candidates use it to gather feedback, see what your feedback is and how useful you find it. Then we'll answer some questions if you have any right at the end here. Okay, what I'm going to talk about is why we visualize time. So what we're looking at here is a simple table, and it's just a table of communications, something you're probably very familiar with. Each row in the table has a sender, has a recipient, and various other things about the communication. In this case, it's emails, so a subject line, the actual body of the email, and so on. And that can be visualized in a number of different ways. So in a traditional node link chart, you may want to look at who's communicating with whom else and the pattern associated with those. But what we've discovered after having done traditional graph visualization for a number of years is that a lot of data that is rendered in a graph format also has what you'll see in the second to the last column there is a date timestamp associated with it. And that date timestamp adds an entirely new dimension to this data. In this case, looking at communications, we may not want to understand necessarily just who's talking to whom else, but when those communications happened, and look at those patterns over time. So what happens when you have graph data with connections that has a date time associated with it? Now, almost always, the date time is associated with the link, not the nodes. So in this case, it's not that the sender or the recipient themselves have any sort of date time, but the communication sent between them, the email itself, has a date timestamp. So when we want to interrogate and investigate that data, we need a way of understanding how things and how those patterns show themselves over time. So this is not a new issue. Certainly looking at data over time is something that people have been doing for many decades. And there are a bunch of different techniques that have been around for a long time. So these are just some other examples of ways that people have looked at timelines in the past. So your traditional calendar view that you see over there on the right, which is helpful for showing active days. So for example, you see 4 days, 5 days in December where green things were happening, and 3 days in August where yellow things were happening. And that probably means something to whoever's looking at this data. But that doesn't understand or show you any connections between the events that you're looking at on the calendar. How might the green and the yellow things be interacting with one another? At the top there, we're looking at what's more of a heat map. So trying to understand when events are clustered in time, when you might see a distinct density of events over the course of a few days, a few months, however long you might be looking at, and when you might see less active events. But again, while that might give you a sense of what activity or what patterns of time, what ranges of time you might want to zoom in on, it doesn't actually show you any attempt to see how those things might be linked to one another. Now, down there at the bottom right, we see a traditional Gantt chart, which is something that's been used in project management for quite a while. And you're starting to get a sense of how things might be linked, because you have these projects or these phases of the projects, and then you have dependencies between them. So Mike Smith can't start on the document system until he's complete with the analytics system, for example. And so there's a dependency or a link between those. But it's a very sort of hierarchical view. You have X happen, then Y happen, then Z happen. When in reality, oftentimes if you're investigating data, then you have a lot of back and forth between various events, and it's not just strictly that one flow after another. And then there at the bottom left, you see what an example of for a stock ticker, where you're tracking something's value over time. But again, you're not really able to understand causality or connections between items. You're just looking at a single item's value. So none of these are particularly the right way of investigating connected data over time. And that's why we created a new product called KronoGraph, which shows a new way of interacting with and understanding this kind of data. So what I'm going to do is I'm going to hand it over to Dan, who's going to take over here and show you KronoGraph, show you some examples of where we've taken some different data sets that have a time element and how KronoGraph can be helpful at showing the patterns over those data.
Okay, thanks, Corey, for that. And yeah, welcome everyone. Thanks for joining. Plan today is I'm going to show you a few examples of the use cases for KronoGraph, how it can be used. I'll talk specifically about use cases. Obviously, as Corey said, we are making this available for people to try out as part of an early access program. So the best way for you to find out is to try it. But hopefully you can see my screen here. This is the site that you'll get access to if you take part in that program. Just like our other products, Regraph and Keylines, KronoGraph is a toolkit that lets you build timelines into your products. It's a JavaScript toolkit. It works for both React and plain JavaScript. And I'm going to show you some things that I've built with KronoGraph to give you an idea of the possible use cases. So to start out, let's start with something really, really basic before we get onto the cool visual stuff. We'll start with a credit card fraud example, but before we do that, just to look at the most simple possible timeline you can imagine, this is a single event in time. What we're looking at here, in this case, is a credit card transaction. There's a lot of information visible here on the screen. It's basically telling us that somebody called Mark spent some money in Walgreens. In fact, he spent an awful lot of money in Walgreens. I don't think most people spend that money. And Mark is disputing that transaction. He's saying that wasn't me. And it has a date, 2nd of April, 2014. So this is what we call an event. Events are what appear on our timeline. And events often, not always, but often refer to specific entities, people, stores, in this case, Mark. And Walgreens. This is an event which connects Mark and Walgreens at a specific point in time. So once we start loading multiple events, that's when things get interesting. If I just zoom out here, we can see some other events going on Mark's timeline, another disputed transaction here. And if I filter in some all of Mark's normal day-to-day credit card usage, we see even more data appearing. And as you can see, the KronoGraph is adapting to the data that we're loading in, and it's nicely animating between states. And we're seeing a kind of sensible view in this case of Mark's spending activity. So in this case, we're going to look at a use case around credit card fraud investigation. Mark has claimed that this wasn't him. He didn't spend this money. So we might want to try and understand what are the patterns of behavior around this transaction, and can we learn anything about what might have caused this fraud to happen. So one thing we can say is, well, let's have a look at what Mark was doing around about the time he had this transaction. And we can see Mark isn't actually using his credit card much at all. He's only used it once, anywhere close to that fraudulent transaction. He spent quite a lot of money at Walmart. I'm going to pin that transaction to my timeline. It's kind of like my personal timeline here at the top, and I'm tracking that event because it's interesting to me. What I can now do is bring in some more data, and I've got data on a lot more people. You can see the timeline is starting to get a bit more crowded now. We have a bunch of different credit card holders. Some of them are flagged in red because they have disputed transactions. I can just hide the others, and we can see some people who've got disputes, and it's very easy to spot another person here, Paul, who has a very similar pattern to Mark. We can see close together on the timeline, both of these people have reported disputed transactions at Walgreens around about the same time, 1 day apart. So there might be a connection between these, and if I zoom in a little bit, I can see what else was Paul doing around this time. And I can see Paul as well spent a lot of money at Walmart, very similar time to when Mark did his. So we might conclude that there's perhaps something in common here. Maybe credit cards are being cloned at Walmart. It's a simple fictional example, but I wanted to use that to give you an idea of the basics of Chronograph. We've loaded some simple transaction data, and already we're starting to recognize behaviors and spot sequences of events that would have been very, very difficult to spot had we just tried to look at this as a network graph, or had we just eyeballed the transactions in a long list. Chronograph lets us create these timelines. It lets us interact with them, zoom, pan. It lets us focus on individual players in the timeline, and it lets us pivot the data around and build up views or sequences that we want to investigate. Let's quickly move on to a slightly larger, more realistic example. Instead of just a few tens of transactions, what if we had thousands or tens of thousands or even millions? This is an example of some share trading data. We're just looking at one stock, fictional company called Megacorp, and we're looking at some share trades. These are some organizations, investors who have bought or sold shares in this company. And what I'm going to do now is zoom out, and as I zoom out, we're going to bring in more and more data. And at each level of zoom, you see the view starting to get a little bit more crowded. And as we get to the point where there's really not enough room to display these transactions, what Chronograph does is it intelligently aggregates the information so that there's something sensible at each point. So at this level, there's really not any point in showing the individual transactions, but we can show them as little rectangles, red for sells and green for buys. And as we zoom out further, even those transactions themselves start to merge together, and we get a general sense of the activity on each day. This particular day was mostly a selling day for this company, and this day was mostly a buying day for this company. And as we zoom out further, we can start to see trends throughout the year. I can now start to see a huge amount of buying across the board from these companies after some record profits were announced, or a lot of selling across the board, and general negative sentiment in the company in the months leading up to that profit warning. This is a meaningful view. Even though I've got thousands of events on the screen, I've got a meaningful view, and I can learn something from this level. And if I need to zoom in, I can. In this case, we're looking at an insider trader investigation. If I bring in some individuals, individual share traders, we get to the point where it's not even possible to display everyone by name because we have too many people. So again, Chronograph has aggregated that information. I can see here just a row summarizing those individual investors. But what I can do is I can zoom in. I take away the companies, and as I zoom in, Chronograph will again open up this group, show me individual traders, and now I can get to the level of information I want, which is, you know, who was buying shares just before the profits were announced, and are they perhaps suspicious? Can we detect patterns of activity, such as this person here, who seems to also be dumping a load of shares before a profit warning went into the news? Again, by being able to zoom in from both a very high level view of overall sentiment and then switch to a view of individual trades is really, really powerful, and something that Chronograph does really well. All we've done is loaded this data, and Chronograph has handled how to represent it and how best to display it given the amount of time that you're looking at. So we've looked at a couple of financial examples or fraud examples. We think Chronograph is applicable to a whole variety of industries. Many of them, I think there are many people on the webinar today and joining from a number of different industries. So I wanted to give you a little tour of just a few other use cases to maybe inspire you as to what could be done with these timelines. I'm going to look next at an example, a completely different example from the cybersecurity world. Here we're looking at network traffic analysis. So we're looking at packets of data sent, in this case, between my laptop This is genuine data from my laptop. I left it running for not very long. You can see on the timeline, it's about 15 seconds of my laptop's network card doing things, and already we can see on the top here quite a lot of activity. So what we're seeing on the top is keylines or regraph, one of our graph visualization products, and we're looking at the connections between my laptop and the various other addresses it goes to. And if I find one that's interesting to me, in this case, this particular website, I could double click it here and ask the chronograph to show me just a timeline of my interaction with that other website. So although the chronograph can be used standalone, and you've seen it being used standalone in the previous examples, it works really well side by side with a graph view, because I can explore both the connectivity in the top view and the individual sequences events in the bottom. For example, I might want to know what else was my computer doing while it was talking to this particular website, and so I can kind of use the chart to pivot around, bring in the wider picture, and then I can start to have a look at the individual addresses which my computer went to, and I can see that just the act of going to one website triggered a whole avalanche of other activity on my machine, going to CDNs to load content for the site, or looking up the site using a DNS server, or this is probably me going to Google to find the site that I went to before I actually went there, and moving from one to the other and being able to interact between the chart and the timeline is a really powerful way of seeing two sides of the same data. In the cybersecurity world, we could be looking at some kind of incident forensics, analyzing what happened during the course of a cyber attack. But we can use the same techniques in other walks of life too. We could use it in social network analysis, or intelligence investigations, where we're looking at connections between people and their communications. Corey alluded to this at the beginning of the webinar, and asking how did those communications play out over time. So in this third example, I have a network, again using our graph visualization tools to show a network of people and their telephone communications. Networks are fantastic for doing things like showing me who are the clusters. So we've used our Graph Toolkit's analysis module to identify 4 clusters, the blue, the red, the green, and the orange. And I've passed that information into the timeline on the right, so we can look at the timelines of the individual clusters. So if we were to look at this orange cluster here, we could drill down into the individual communications of the people in that group. And again, as I hover over nodes in the chart, I can see them in the timeline on the right. Or if I hover over people in the timeline, I see them in the chart. And this allows me to really understand this network in a way that I couldn't do with a network alone. For example, if we look at this person here, looking at the charts, she seems like quite a key player. She bridges a lot of these groups. She's a kind of a bridge between the green group and the red group and the orange group. If I focus on her individual timeline, I start to see how that activity played out. I can see, in fact, she really only spends a lot of time talking to one person in that green group. Most of the time, she's not really connected to that group at all, and her connections to the red group are limited to one very short burst of activity. It looks like she sent maybe 4 zero duration, probably text messages to someone in that red group. Never got anything in return. So in fact, by delving into the timeline, we learned that this person actually probably is not a very good bridge between these two organizations. But by looking at the chart alone, we wouldn't have seen that, and we might have been led to believe that this person was more influential than they actually are. So by having these two views together, a timeline view and a network visualization, you really unlock a lot of insight into what's going on in networks and communications data sets. So we've looked at fraud investigation. We've looked very quickly at cybersecurity and communications analysis. I realize this is a very quick lightning tour, but hopefully it's inspirational. The last example I wanted to look at was kind of law enforcement crime investigation use case. And I wanted to show it partly because it gives you an idea of the power of combining multiple data sets together into a single timeline. There's something that all time data sets have in common is that time axis. And no matter what the data set is, no matter how different it is, because they all have that time stamp in common, it means you can overlay them on the same timeline and learn really interesting things. This is really important in the intelligence and law enforcement community, where you're getting data from multiple data sources, and it's often only coming together at the point of the investigator looking at it and trying to piece together what happened. In this example, we've got some data representing some kind of crime spree where someone has stolen a vehicle and they've driven on some kind of rampage through Manhattan. Fictional data, of course, and we've put these observations, these witness statements, people saying I saw the vehicle or people finding this vehicle abandoned. We put those on a map using key lines, but if I double click on these events on the timeline, I can kind of move through this sequence of events and see it playing out on the map. Where this becomes really powerful is then if I was to load another data set in here, a totally different data set, which is a data set of telephone call records, which we've obtained as part of the investigation. And now I can see who this person was calling and overlay those calls on the same timeline as this crime. So I can look, for example, at around about the time that this person was suspected of committing a robbery. We know roughly where the person was because we can see which of these observations happened within the time window we're looking at. But we can also see these outgoing phone calls. We can see that our suspect called this number 1, 2, 3, 4 times during a very short period during this this crime. So we've got a lot of information about what was going on simultaneously. We might want to investigate the owner of this phone to see what part they played in things. And by seeing that data overlaid in the kind of background story of what's been going on from other data sources, you get a very powerful way of understanding, in this case a crime, but understanding any data set, any kind of investigation, forensic analysis of cyber attack, a crime, a fraud. It's a very, very powerful way of doing things. So we're running out of time, so I think we'll move on to the Q&A. But basically, as Corey said, if you want to try Chronograph out, it's full of great documentation. It's full of example code snippets that help you understand how to build these timelines. And the early access program is open right now. So I think I'll leave it there. Just a reminder that if I haven't covered your use case today, I mentioned only the first, I guess, 3 use cases in this long list of use cases we've identified. You may not even be on this list and have some ideas. We'd love to talk to you and find out how we can develop this product to meet your use case. So I think with that, I will hand back to Corey, who hopefully has some questions. If you have any questions, please do post them on the Q&A section of the webinar.
Great, thank you, Dan. So Dan has the link to our early access program up on the screen right now. Do absolutely feel free to go to that site and fill out the form, and we'll get in touch with you about getting access to keylines in early access, which means, as I mentioned before, it's not available for sale, but you can certainly play with it and see if it fits your use and give us feedback, and we'll be happy to talk to you because we're at the stage of product development where we really do want to understand how this fits our customers' needs and whether it's the right solution for looking at things that have time. So we had a few questions come in over the questions panel, so I'm going to try to take those as we go. The first one I have here is that can Chronograph also display relationships between events within an entity? So I think I'm not quite sure I totally understand this question, so feel free to reach out to me afterwards if I don't answer it the way you're expecting. But I think the answer is that links go between multiple entities or between no entities. So you could have an event that, as Dan pinned up there, that just shows a timestamp where something happened, but is not linked to any entity, or just linked to a single entity or linked to multiple entities. So if you wanted to show interactions within a single entity, I think probably the way to show that in Chronograph would be to split that into 2. But there may be other ways, so definitely you can reach out to me or Dan after the fact and discuss exactly what you're aiming to do, and we can see whether Chronograph is a good fit. The next question, oh yeah, go ahead, Dan.
I was just going to add another example of that is where you might have something that can be an event that can also be considered an entity. So a good example of that is social media, where somebody makes a post the person might be the entity, the post might be the event, but if someone else then likes that post, you have an event which kind of refers to another event. So it is something we've been experimenting with. There's lots of different ways of showing it. You can link events to each other, but you can also kind of pivot, where 1 minute the people are the entities, the next minute the social media posts are the entities, and you can get some really interesting views there. So yeah, definitely keen to discuss that use case with you offline.
Yeah, as Dan said, that's something we're experimenting with now. The next question I have is, can Chronograph show event duration? And the answer is yes. We do have, just like in Keylines, events can either be an instant in time. Most of the examples that Dan showed were events that took place at a specific instant, but we do have the ability to have a start and an end time. So that's what Dan is showing you now.
Yeah, simple example here, the Gantt chart variety, but again, we're very interested in the kind of data you have, and the goal is to be able to visualize exactly what that data represents. So this is one way you might show duration with a solid bar.
Okay, the next question is about how Chronograph might work with regraph. So Chronograph is designed to work alongside either of our traditional node link chart visualization tools, Keylines and regraph. And to do so, we have two different aspects to our API. So we have both a React-focused API and a JavaScript-focused API. So if you're using Keylines alongside regraph, you're most likely going to want to use the React side of the API. And Dan's showing you the difference there. The ultimate underlying functionality between the two is the same. It's just how you build your tool with it. The next question is about performance. So one of the interesting things that we've learned over the past several years of building graph tools is that the idea of wanting to start with a large volume of data and then filter down to a smaller volume is really powerful, and it's incredibly common too. That's just what most people want to do. And one of the things about Chronograph that makes it particularly apt for very large volumes of data is that you don't actually have to render any individual data elements. So you saw in Dan's example where he was very far zoomed out and was showing a lot of time and a lot of events. We turned the view from looking at the individual events themselves into that more of a heat map view. And the benefit of that is that you get very, very good performance when you don't have to draw tens of thousands or hundreds of thousands of things on the screen all at the same time, but just represent them with the density of a color of the block on the timeline. So I would say that the performance is very, very good, and it's really limited only by the amount of data that you pass to it and the amount of memory that you can hold in the browser, but that's usually well in excess of what it's helpful to show in Chronograph anyway. The next question here is, what format does Chronograph use to ingest the data? So we talked about the React versus the JavaScript APIs. In both of those cases, the actual data model itself is a JSON object. It's just slightly differently structured depending on which one you've chosen. But Dan is showing it to you now. It's basically just a dictionary of the entities, the events, and the interactions between them.
Yeah, it's a very simple data model. It's not quite the same as the Keylines or regraph data model deliberately, because the model is much more flexible. As Corey said, you can have events which connect 10 nodes together or none, so it's not quite a graph. It's very easy to switch from one to the other though, and it's exactly the same data format whether you're using the React or the JavaScript version of Chronograph.
Okay, the next question is about the early access program. How long will it last? We don't have exact dates for that yet, because the idea is that we want to put this in front of some people who are going to use it, build some tools with it, see how it fits what they're trying to do, and then make edits to the tool, the functionality, add new things, fix bugs, and that sort of thing. So it's hard to say exactly when that process will be complete. It could be quite short if everybody who uses Chronograph says it's exactly perfect and have no suggestions for improvement. But we think more likely there will be some suggestions. So we're going to take those into account before we go to a final version. But that doesn't affect how long you would have access. That's a discussion we can have on an individual basis. As long as you're actively using it and giving us feedback, then I don't see any reason to limit the amount of time that you could spend with Chronograph before we move to a generally available version. And the very last question, because I know we're out of time here, is talking through the data privacy aspect. So like our other tools, Chronograph is deployed to you. We give you the library and you build it and bundle it into your application and then deploy it off to your end users either as a hosted solution or as an on-premise solution. So there's no dependency back on our site or anything like that. We don't host the library ourselves. So the data never is seen by us. And so that's entirely within your control. So with that, that was the final question I had. So definitely feel free to reach out to us. You can fill out the form there at the Early Access Program if you're interested in trying it. If you have any questions for Dan or me specifically, then our emails are at the beginning of this presentation. And as I said, it's being recorded. So if you want to take a look later or share it with some people who weren't able to attend live, then we'll send you out the link shortly as soon as it's done. Thank you very much.